Hi all. See, we are waiting for others. Let me share my screen and wait. Hi Rohit. I hope you can hear me, right?
Hello.
Hello.
Yes.
We'll just wait for 1 minute. Let's see if Sarangs is also going to join, or maybe we can give it a start and he will join in. So let's wait for 1 more minute for him. Okay. I think let's give it a start because we have a limit of time as well, right? So let's just quickly look into what we have done until yesterday. So we did one minor statistical test. This was just to ensure or to verify if my features are normally distributed or not, right? So we did a small Z test. We did a small normal test. This is also known as a Z test because, as you can see, we are finding the Z score or the Z value, and then we are finding the P value, right? So this is similar to what we had already done earlier, right? When we used Excel and we used the norm dist and norm s INV function. So from there, we used to find out the Z score and the P value, right? So that's what we have already done earlier in Excel, which is similar to what we did in Python now. Uh, okay, give me 1 minute. Okay. So, yes, so other than that, before that, we have looked into the two sample tests and the revision of that. We have also looked into why we are doing the sample test or why they are called test for independence. And we looked into how we can write certain pieces of code to accept or reject the null hypothesis. So let's just continue from there and give me 1 minute. Okay, sorry. So yes, so yesterday we were looking into the theoretical aspects of the chi-square test, right? And we came to know that this is the chi-square test statistic that we need to figure out, given by this sign, which is the chi sign, and there we have to do a summation kind of a formula, and we need to put the observed value uh, along with the expected ones. We are simply standardizing here, that's why we are taking a square, right? And then what we are trying to do is that along with this statistic, we will be using the degree of freedom, which is basically something that we have already explained earlier, right? If I have R rows and C columns, the degree of freedom becomes R minus 1, C minus 1, right? So we have also looked into the fact that sorry, to perform a chi-square test, we need to have an observation table. Okay, so we need to have an observation table, and then only we should be able to do the calculations, because we have looked into this table, which is known as the observed table or the contingency table. This table we also called a two-way contingency table, because I had two features which I'm trying to compare, right? And then there are four values which I can take a summation of. Now, before we go into the practical implementation, let's just quickly look into what is the expected count. Okay, so expected count or expected values will be calculated for each and every blocks here, right? So just like we have A, B, C, and D, these are the observed values which we find from the data. Similarly, we need to calculate the expected count of each cell, and the expected count is nothing but what we intend to see if the two variables were independent, which means I'll assume, okay, just for a certain period of time, I will assume that the null hypothesis is true. Okay, I'm here to do this test so as to prove the null hypothesis wrong. I know that, but just for a minute, I'll understand, or I'll assume that, let's say the null hypothesis is false, or the null hypothesis is actually true. And then accepting the null hypothesis, I want to find the expected value. So the expected value is found out like this. So it is row total multiplied by column total. So A plus B multiplied by A plus C divided by the total value A, B, C, D. Then it gives me the expected value for A. Okay, now in the same way, I can try and find the expected value for each and every cells, right? So expected value for the count that we have in cell number A is A plus B multiplied by A plus C divided by the total number, right? The one for B will be B plus A multiplied by B plus D divided by this. Okay, now why to do this in a manual way? We will be using our functions to calculate this, and we already know yesterday we quickly touched base into this chi square underscore contingency. This function can be called, and here the parameters is the observed value. Rest all are actually optional, so I'm not going to pass them. So I'll already, or I'll only pass the observed value as one of the inputs. This is going to be an array, so I'll need to create that array first. So let's first create that array, and then it is going to return me the chi-square test statistics. It's going to return me the p-value. It's going to give me the degree of freedom. Although degree of freedom I can myself also calculate, right? Because I know the number of rows and columns. And the fourth and most important thing, it's going to give me the expected ND array, or this ND array is going to contain the expected values. Okay, so that's exactly what is going to happen here. Now I need this value out of this function. So what I'm going to do, I need to take some data set first. So let's just chart out what I have to do. So to perform this test, I need to load the data. Okay, then I need to figure out the expected values from the no, sorry, I need to figure out, first of all, I need the observed data set, right? So I need the observed values from the data frame. Okay, this I can calculate. There is already a function in the pandas library. I can use that. And then I need to find the expected values. Okay, once I find the expected value, now I can do or perform the chi-square test. So point number 4, I will be performing the chi-square test or the chi-square test and find the chi-square statistic. Okay. Uh, Now, how to validate whether I accept or reject the null hypothesis. Okay, there comes a small confusion. I will not say this is just a process that we need to follow. So the process will be something like this. Let me just note down the strategy. So this is my overall strategy, and then what I'm going to do, find the chi-square statistics. Finally, apply some, let's say, method to compare the chi-square statistic with the critical value. Okay, this is one way. Or get the p-value and compare with the alpha value. All right. So this is exactly what we're going to do. Why is this the case? Let's just quickly understand why we have written point number 5. Why we have written this is because this is exactly what we used to do earlier as well. If you remember, we used to have a normal graph like this. Okay, we used to have some kind of a critical value. Let's say ZC is this, right? And then we used to find our actual statistic. Let's say the statistic falls over here. If the statistics, let's say this is my observed Z or the Z that I found out, ZF. So clearly ZF, something that we have done in one of our past videos as well, right? When we were manually doing the calculation, when we were doing Excel-based calculations as well, we found this ZF and then we compared. Is the ZF greater than or equal to ZC? If this is the case, what we do? We reject the null hypothesis. If this is not the case, we cannot reject the null hypothesis, right? Because the ZF falls into this acceptance region. It can fall into this region as well, right? So it can fall into any side of the graph. In this case, if we are looking at both the sides of the graph, we call that a two-tailed test. But in the examples that we have seen earlier, we have only looked into this, okay? So we have only seen a one-tailed test kind of thing. So that's what we are going to do over here as well. I'm going to take a dummy example and then we can find whether this value, in our case, what will ZF be? In our case, the ZF is going to be the chi-square statistics. So chi-square statistics is something that we are going to find. And then we are going to compare that with the Zs. Okay. How do we get the ZC? We get the critical value. Okay, we are going to find out the critical value, which is going to be my ZC from a Python function only. So I get both. I get both the chi-square statistic as well as the critical value. I simply do a comparison like this using an if-else statement, and I should be able to tell you whether I accept or I reject the null hypothesis. Now that's one way, but this is a complicated way, right? This is something we don't always understand. So we have already decided we are going to use p-value. So we are going to look at this technique. Of course, we are going to look at this technique, but mainly we are going to do this. So we'll find the p-value, and we have already defined the alpha as 0.05, right? So if I have p-value less than 0.05, then I'm going to consider that things are fine, right? And then we can reject the null hypothesis if that is the case. If that is not the case, we cannot reject the null hypothesis, right? So that's exactly what we are going to do. Let me just write it over here. So the first thing that we are going to do, okay, find chi-square statistic and find the chi-square statistic and the critical value and compare them, right? And the second thing that I can do, so I'll write or. In this case, I'm going to do both. Okay, so that's not going to be a problem. The second thing is find the p-value and compare with alpha, right? Let's see how we can do that. Now, to do this, as I have already told all of you in the last class as well. So we have these Python libraries where we already have some data set imbibed. Okay, so we are going to take an example like that only, where there is already a data set inbuilt, okay, within one of the libraries that I have. So that library is the Seaborn library. Okay, let me just quickly go up and see if I have imported Seaborn. Yes, I have imported SciPy. Yes, I have imported NumPy. I have imported imported pandas. So I have Seaborn library, and in Seaborn library, there is a data set which is for, let's load the restaurant tips data set. So this is as simple as a data that contains details about transactions that has happened in a restaurant and how much tip amount as compared to the actual bill amount was paid by a customer during each and every transaction or each and every purchase which has happened in the restaurant. So how I load that data is something like this. Let's say I'm going to call this data set as a data set itself. So data set, let's say, is equal to SNS. Okay, SNS is the library that is for Seaborn. So SNS dot load underscore dataset, and here I'm going to pass the name of the dataset, which is going to be tips. Okay, now how did I find this? You can simply take this, okay, and you can come over here. You can go to the documentation of Seaborn, and you can clearly find out all of the data sets which are already present inside the data. Okay, so if there are more than one, I was only aware of this one thing, but if there are more than one, I'm sure you can find that out from this list. Okay, you can use get dataset names as well. So for example, what I can do, let's say I can SNS get dataset names, and I can, if I run this, then it's going to take some time, but it's going to give me the names of all the data sets that is there with me on this system here with the SNS library that I have. Okay, so with Seaborn, the current version of Seaborn that I have, there are certain, let's say, data sets which are already available, and they should be displayed by this. Also, I can look into this function itself, and it should be able to give me the output. Okay, now this sometimes takes a lot of time, and sometimes it times out as well. Okay, it gives some kind of HTTP request and so on. So no problem. Let's see how we can actually get rid of that. Let's see if I'm trying to load the data set, if that is going to work or not. Okay, give me 1 minute. Let's see if this is going to load. If this is not going to load, and then I'm going to download the data manually. I believe this is trying to load the data from somewhere. So I don't know whether it's going to, yeah, I expected so that it is going to time out. There is some problem actually on my system itself. I'm sure this will work for you, but this does not work for me. So I'll just comment this part and I'll say this is one of the ways we can load the data, but this above requires internet connection where I have some problem, but I hope you won't be having some problem. So let me just download this CSV file, and then what I'm going to do, I'm just going to import that as a pandas thing, right? So let me just, I'm just opening that into a different page. You will not be able to see that, so give me 1 minute. I'll just download the CSV file. It's also available for free. Okay, so I'm just downloading it. I'll also show you from where I have actually downloaded it. So don't worry. I'll just take the link and I will put it here. I have got the link now. So if I give this link over here, this is the data set. So it has 4 columns: total bill, tip, sex of the customer, whether the customer was a smoker or not, on which day the customer came into the restaurant, at what time, or what kind of an order was made. Was it a dinner, was it a lunch, was it breakfast, and kind of, and what was the size or the table size. So let's say I am this person here. Okay, I have spent a total bill of $10.34. I've given a tip of $1.66. I'm a male person. I'm not a smoker. I went to the restaurant on a Sunday and I had a dinner with 3 people. Okay, so totally we were 3 people sitting on a table where I was billed. So I've already downloaded the data. You can see it over here now, tips.csv. So let me just do one thing. Let me do data set is equal to pd dot read underscore csv tips dot csv. Okay, so I've just loaded the data. So as of course, see the sample of the data. Okay, this is the first thing which we do, right? So data set dot head I'm going to do, and I can clearly see what is happening over here. Now what I am going to do, or what my test is going to do, is that I would like to know the chi-square test that I'm doing, let's say this will be applicable on the categorical fields, right? So categorical fields, I can clearly see there is a sex field, which is the categorical field. There is a smoker field, which is a categorical field. There is a day field. There is a time field. Okay, let me take the interesting fields. Okay, day and time may not be really interesting for me right now, but as per my requirement, let's say the interesting field is going to be the sex of the customer and the smoker flag of the customer or not, right? So using those, I would like to create the observed values table. Okay, so how do I create that? Let's say data set dot I can say this as data set underscore table is equal to pandas. Okay, so I'm again giving a call to pandas library PD, and in PD there is a function called cross tab. Okay, now what I'm going to do from this cross tab is that I'm just going to pass both my groups, okay, both the columns. You see, to create the observed table, I need both the groups, right? In this example, I have both the groups, and here in the columns, I have the different values. Okay, so I don't need the column names. I just need this part of the data. I've already told you yesterday, right? That most interesting thing that we need to look into is this. I just need this. Okay, if I have this much of part, I'm done, right? So that's exactly what I'm going to do. In this function, let me just go back over here. I'm going to say data set, and here I'm going to take, let's say, the sex column, okay? And then in the next one, I'm going to take the smoker column. Okay, so I have taken both the columns, and then let's see how this table is represented. Okay, you see what is happening here. It is representing, it is not giving me the totals, okay, but it is giving me the values. There is also an option in pd.crosstab to show the totals, but it's not really required for me, so that's why I'm not doing it. So I just need these counts, and from here also I get a lot of information, right? So I have females. The total of females will be 54 plus 33, out of which non-smokers are 54, smokers are equal to 33. Okay, so in females, I have this kind of a ratio when it comes to the non-smokers. Okay, or smoker to non-smoker kind of a ratio is something like this. Okay, similarly, I can find that out from male. Okay, now obviously, as we have already discussed, so chi-square test is for comparison of two categorical variables. So what is going to be my null hypothesis? Let's just write down over here just for the record. Null hypothesis and smoking habit of my restaurant customers are independent. Okay, and then the alternate hypothesis is going to be this. Okay, so this is exactly what is the setup that we are trying to find out. Okay, this is exactly the setup that we are trying to find out. Okay, this is the value over here. Let me just give me one more. Okay, now what we are going to do now is that we have got the observed values, right? We have got the observed values. But if I look at this function over here where I need to pass the observed value, it is an array. Okay, but if I look at this data set table, if I take a type, okay, is that an array as well? The problem is it is now a data frame. I have to convert this first of all into an array, right? Or otherwise I cannot do anything. So what can I do? I can do a very simple thing called values. If I simply do a value, it gets converted into an array. So you take any data frame, do a dot values. Let's say you take this data set dot values, then it simply converts all the things into an array, right? So that's a cool trick. It's really a very, very useful trick. And that's the trick that we are going to use to get the observed values. So getting the observed values. So what we're going to do, observed values, right? Observed values is this. So I have got my observed values. Now I need the expected values, right? I need the expected values. To get the expected values, to get the expected values, I'm just going to save time by writing small here. To get the expected values, I call the chi-square contingency function. Okay, that's all I'm going to do. So what I'm going to do, let's say values that I am getting. will be sp.stats.g2 underscore contingency. This is the name of the function, right? Let me just quickly check. G2 underscore contingency, G2 underscore contingency. Here I'm going to simply pass down my array. Okay, that's all I have to pass. Everything else is going to be an optional, right? Everything else, this correction and this lambda thing is actually optional. I just have to pass observed, and observed is actually this. Okay, so I'll just pass this and it gives me the values. Okay, it gives me the values. So this is the output. This is the output of the values of that I have got from this function. Now there are many values over here. Am I interested in all of them? The answer is no. Let's go back and see why I'm not interested in all. I have got the test statistic here. Okay, you see I've got the test statistic which is over here. I'm interested in this. Okay, I have got the p-value. Okay, I'm interested in this. uh, this is what, this is the degree of freedom, and then this array is my array of expected values. So as of now I'm interested into, let's get the expected values, and I can get that using, let's say, expected values. Observed values I already have, so expected values will be equal to values that I have got, and then 3. Why is this 3? Because this is a set, as you can clearly see from the brackets, right? So it starts from 0, 0, 1, 2, and 3. Third value is an array, so I get the array. So this is observed values. Expected values, and here I have the observed values. So observed values I've already got. Let's see if I've got the expected values. The answer is yes. Right, so these are the observed values, these are the expected values. Clearly you can see there is not much difference, right? If you take a round, it is almost the same. So the values that I get expected is almost the same as the observed values. This already gives you a hint, but I'm not going to tell you the answer right now. Let's do the test and then we'll find out what is going to happen here. The rest of the values also we know, right? We also need the rest of the values. Okay, so that's also something that we need to get. So for example, this is my degree of freedom. Okay, so get degree of freedom. Okay, what is the degree of freedom? In my case, I know that already, right? It will be number of rows minus 1, number of columns by 1. But in this case, it is equal to 1. Why? Because that's the degree of freedom of this table. Okay, number of rows and number of columns. The degree of freedom is calculated based on the input data. In my case, this is the input data, right? This is not the input data anymore. I have converted the input data into a dataset table variable where I have the two-way contingency table. So contingency table becomes my input data. That's my degree of freedom. Let's say DDOF is going to be 1, or I can also say values 0, 1, and 2. So I'll say values in bracket 2, and let's just print and see if it gives me the value. The answer is this. Okay, let's also get the rest of the values. Chi-square statistic. Okay, what is the chi-square statistic? Chi2 underscore statistic is equal to values 0, right? The 0th value is the chi-square statistics. Okay, I hope you are able to follow me, because this is just as per the documentation that we've seen over here. The first output is going to be chi-square test statistics, second is p-value, third is the degree of freedom, fourth is the expected values in the array. I get the chi-square statistic. Okay, now what can I do? Let me also get the p-value. Okay, p-value from here. So p-value is going to be p-value, let's say, is going to be values, and the p-value will be what? The second value, right? So it is 1. So let's say what is the p-value? This is the p-value. Okay, so this is the p-value as per the function that I have already executed. Now I have extracted all the values inside this set into individual variables so that I can play around. Now the first play that I'm going to do, I already know what is the thing I need to do. Compare chi-square statistic. Okay, I have to compare this with the critical value. I have not got the critical value over here. Where is the critical value? Okay, let's try to find out from where I can get the critical value. To get the critical value, okay, to get the critical value, what I need to do is that I have to use a function, right? I have to use a function, okay, which is going to give me the critical value. That function is known as get the critical value from PPF function. Okay, the name is really funny, but this PPF function is a inverse, okay, of CDF function. So cumulative distribution function is something which we have already seen. PPF is simply the inversed values, a function containing the inversed values of the CDF function, which helps us give the critical value. So how do I get the critical value? Very simple. I just have to find out the critical value from there. So I have to find out the critical value using a formula. Okay. So I'm writing critical value. Critical value is equal to G square. This is a library which is part of sp.stat. So let me just write sp.stats over here. There is a function called G square. In this G square function, or in this module, actually, there is a function to get the PPF. So in the PPF, I have to pass on the degree of freedom and the confidence interval. So these are the two inputs I have. The first input is the confidence interval. The second input is the degree of freedom. I've already taken the degree of freedom here in this variable, so I've passed it over here. The confidence interval is nothing but 1 minus alpha, right? Because I already have the value of alpha, which I have already defined, right? So that's equal to 1 minus alpha. This value is given as Q. And then this degree of freedom value is given as df. So these are the parameters which are accepted by this function. We have looked into Python functions, right, where they accept named, let's say, parameters. So we have to call this function using this way only. And then I get the critical value. Okay, you see, I have got the critical value. I have got the chi-square test statistic. If I've got the chi-square test statistic, okay, and I've got the critical value, what I can do using the values, so this I can say first test to accept or reject null hypothesis. Okay, what is going to be the first test? If I have already told you, right, what is going to be the answer? Chi-square statistic, okay, has to be greater than. Okay, the chi-square statistic has to be greater than or equal to the critical value. Okay, if the chi-square statistics is greater than the critical value, then I'm going to say reject the null hypothesis, right? So I'm going to say print reject h naught. Okay, else print accept h naught. I can clearly see the answer here as well. I don't need to do this, but then the reason why I'm doing this is because maybe tomorrow or later on, ideal condition, you should create this or you should embody this inside a function. Okay, and then make it a reusable function and call it by passing the values of chi-square statistics and critical value. Okay, so if I give this, I accept the null hypothesis. Chi-square statistic is greater than or equal to, no, give me 1 minute. I think I've done some mistake. Reject the null hypothesis. There is no relation. Yes, right. So we have to accept the null hypothesis. There is no relationship. So I'll just write this over here so that I don't get confused. The features are independent. Okay, and if we just put it over here, I'm going to say the features are dependent. Okay, so by this first test, using the critical value and using the chi-square statistic, I clearly come to know that in this kind of a setup, in this data, the two features that I've used is first of all the sex of the customer and the fact that whether the customer is a smoker or not. Basis these two are independent. Okay, they are not related to each other. They do not impact one another. Okay, now let's do the second test. Okay, second test to accept or reject the null hypothesis. I'll just take a quick copy paste and simply I'm going to say p what is the name of the variable that I've given? P-val, sorry. Okay, P-val. What should be P-val? P-val should ideally be not greater than equal to less than equal to alpha. Okay, if it is less than equal to alpha, we reject the null hypothesis. If it is greater, we accept the null hypothesis, right? That's what we do, right? So clearly the answer is going to be the same. Whether you use this technique or this technique, entirely up to you. The reason why we are using this p-value technique is clearly because we have seen earlier, right, that this p-value technique is actually more easy to understand for me rather than this thing, because then there is a concept of this critical value and from where this comes up and so on, because then I just have to visualize my data once more and I have to remember, okay, this is the critical value and this is the test statistic that I've got. Because it falls into this shaded area, that's why I'm going to reject the null hypothesis. But in my case, it does not fall into the shaded area. It's going to somewhere here, okay, because my value is far less, right? My test statistic, chi-square statistics, is like 0.09 something, and my critical value is like 3.84. So it is far lesser than the critical value. That's why I have to accept the null hypothesis. So this one is difficult to understand. That's why this one is taken care of, right? So you can use any technique that you are comfortable with, and it should be giving you the outcome of the tests that we are doing, right? I hope you have got the point. I hope the points are clear. If there is any question, please go ahead. Are there any questions?
Not from me, Bhamik. It's clear.
Okay. Okay. So the
No.
same thing we can do with the rest of the cases as well. Something that I would like you to try, whomsoever is interested in coding things a bit, try to create a function which takes the names of the features. Okay, this is kind of a homework I can give you. So try to create a reusable Python function which will take the data, which will take three inputs. Okay, let's say it's going to take three inputs. It's going to take the first input is going to be the data frame name. Okay, let me just put this over here. The second input, uh, sorry, I think there is some problem over here. Okay, so the second input, I don't know why it is doing this. Okay, so a data frame name, let me just remove this. Okay, this will cause some problem. So data frame name is first input, column 1 is the second input, column 3 is the third input. Output of the function should be the print statement like this over here. Okay, a print statement to state whether to accept or reject the null hypothesis. Okay, okay, try to code this up, but I think using the manual way also we can try to continue and we can look into the next set of the data. So let's say data set, if I look at this data set, I have two more columns, let's say day and time. Okay, are these two related? Okay, so I can again try to find out those values by doing all the exercises that we have done, right? So let's try to get those values and let's see what we can come across. Okay, we just have 10 more minutes left, but this is just to show you how you can reuse the same thing, right? Or maybe I can skip that part and I can clearly go ahead with the next thing, because I think you have understood the point, right? So what we are doing is we are simply doing a test to find out the categorization, or we are trying to find out what is going to be the relationship between one variable and the other variable using the chi-square test. Okay, so we are using chi-square test where we are trying to compare two categorical variables. Okay, so maybe this I will leave this as a homework. So data set head is going to be the data set that you can try and use. Okay, try and let's say as an example, take all the categorical variables in random combinations. Okay, how do you get the list of the categorical variables? You know that already, right? If you simply do an info, you will come to know which all are the categorical variables, right? Sex, smoker, day, and time. right? So maybe I'll leave this until this. So this is going to be the exercise now. You will have to look into this and try to find out if there are any dependence between each and every variable. Okay. Let's move on to the next topic that we have. We just have small time. Maybe what we can do, we can quickly touch base. Okay. And then we can look into okay, so we can do this now, but it's going to take some time. Okay, let's make a close. I think it was quicker than I expected. Let's make a close here. We will continue tomorrow. Yeah. We anyways have less time to continue, so we won't be able to cover the basics of ANOVA within the next 4 minutes that we have left. So let's continue tomorrow, but please do this kind of an exercise, right? I will share you the data set. I'll share you the tips data as well so that you can play around. Okay. I think that's all from me. Thank you. Thank you so much for joining.
Thanks, Bhavik. Thank you.
Thank you.